Models. Looking around an office in 2026, you'll clearly see desktops and complex digital workflows operating entirely on their own. Models like Claude OS 4.8 and GPT 5.5 are now processing millions of tokens of context in a single prompt. They write code, check that code for errors, and quietly fix those errors without any human input. We've transitioned from executing these daily tasks ourselves to managing the autonomous software agents that do the work for us. When you interact with this level of autonomy every day, it creates the sense that a superhuman intelligence simply woke up one morning. It feels exactly like a tidal wave materializing out of thin air and freezing right in front of us. But building an accurate timeline of how we actually got here requires discarding the idea of a sudden miracle. We have to peel back the invisible historical layers operating beneath the screen. What looks like a spontaneous arrival is actually the highly polished surface of a 70-year structural slow burn. If we strip away the autonomous capabilities of 2026, we hit our first layer, late 2022, and the launch of the ChatGPT interface. Before this moment, commanding serious computational power required knowing Python or other coding languages. This simple chat box bypassed that completely. Typing a plain English sentence was now enough to command a supercomputer. That accessibility combined perfectly with an already active global cloud infrastructure. Companies like Amazon, Microsoft, and Google had spent the previous decade building massive server networks for AWS, Azure, and Google Cloud. By opening up their APIs, these tech companies distributed the new capability instantly. They bypassed physical shipping entirely, integrating the technology into billions of existing smartphones and enterprise systems in a matter of months. The 2022 explosion centered on frictionless distribution and interface design, making a previously inaccessible intelligence usable for everyone. Beneath that 2022 interface layer lies the actual engine. In 2017, a team of researchers at Google published a paper titled "Attention is All You Need." This animated diagram visualizes the core architecture introduced in that paper, the transformer. Older legacy systems read data sequentially. They processed text word by word, creating a severe bottleneck as the system struggled to keep up with large inputs. The transformer removed that bottleneck. It allowed the system to perform massive parallel processing. Instead of moving linearly through a dataset, the system could now analyze and cross-reference the entire context simultaneously. By turning sequential reading into simultaneous understanding, the math behind machine comprehension became vastly more efficient. But if we strip away that 2017 architecture, we hit the deepest historical layer. We reach the mid-century computer science of the 1950s, led by figures like Alan Turing. The theoretical equations behind modern deep learning existed decades ago. The math itself is not new. But these early researchers were trapped by the physical hardware of the era. These rudimentary computers lacked the power to execute the massive, complex equations that early AI theorists were writing. This friction led directly to the AI winters of the 1970s and 80s. Theoretical hype collapsed against physical limits. Funding dried up, and artificial intelligence became an academic taboo. The foundational math was solid. It was simply imprisoned by silicon, enduring a decades-long freeze until physical hardware could finally process the theory. This graphic shows the exact moment the freeze ended. The 1950s mathematical bedrock, the 2017 transformer architecture, and the 2022 cloud interface finally aligned. This convergence occurred the moment these isolated variables locked together, creating the high-speed infrastructure needed for the current scale of AI. That convergence is what powers the agentic AI of 2026. The autonomous AI used today represents 70 years of compounding human engineering. Understanding this 70-year slow burn removes the mystery. It reveals the current landscape as the inevitable moment where mathematical theory finally met the physical power required to execute it.